Well, welcome everyone to today's webinar, Utility Mapping in Practice, Design, Bid, Build Without Surprises. This is part of ConnectMe's Mapping the Hidden City webinar series, and we are delighted to have all of you in attendance today. Looks like we've got 60 or 70 people joining us today, maybe a few joining a little bit later. I'm Pete Croswell. I'm president of Croswell-Schulte Information Technology Consultants and also an adjunct instructor with Penn State University. I'll be moderating this event and hosting the Q&A period after our highly regarded panelists finish their presentations. I have over 40 years of experience as a government employee and also as a consultant in GIS and a range of IT domains, including utility mapping, infrastructure asset management, and other IT disciplines that are pertinent to this webinar. I'm a past president of URISA, now known as the Geospatial Professional Network, and I'm active in many professional research and education activities. And I'm really looking forward to this webinar because my history goes back to some of the early tools and techniques for underground utility mapping and GIS database development. Before we get started, we'd like to run a quick poll of the audience to find out where you are from and what industries and sectors you represent. So you'll see the pop-up poll. Please answer those questions and then hit submit. And as you do that, as you're responding to that poll, I'll go through a few other announcements and housekeeping items. So as you know, this webinar will focus on tools and techniques for utility mapping. So important for government jurisdictions, public and private utilities, and all the agencies and businesses and members of the public that rely on this infrastructure. In addition to hearing from the panelists, who I'll introduce shortly, an important objective of this webinar is to get your active participation. And you can do that by entering a question or comment in the Q&A space. Please note that the chat box feature is disabled. There's no need to raise your hand. You can post questions or comments in that Q&A box anytime during the webinar. And the presenters will respond to those questions at the end of the session. We have up to 90 minutes reserved for this webinar. So again, please join in with your questions at any time. I should note as well that audio is disabled for this webinar, but post those questions. We'll go over them at the end. And if you do have a question that's directed at a specific speaker, please put their name into the question. For information about speakers and for the event agenda, you can click the Resources tab at the bottom of your screen. And there's also a few useful links in that Resources section that you can see, and you can access that at any time. This session is being recorded and be available for download on demand after the event, so you'll receive an email notifying you of that and giving you the link for the recording. Before we jump into introductions, we'd like to thank our webinar series sponsor, 4M, for making this educational opportunity available to you. So just before we get started with today's presentation, let's look at those poll results. Let's see what we've got here. All right, so we asked that question, what is your organization type? We've got about 48% local government, state government at about 4%. And then as expected, you've got industry 24% and other. I assume many of those probably represent public and private utility organizations. Where are you located? 93% US. We've got went down a little bit too far. Canada at about 4%, 4% for Europe. We've asked about business sector. So we've got about 8% with land, public administration, transportation at 10%, public information, and then obviously greatest amount, 42%, with public works and utility organizations. For those government jurisdictions, population size, we've got under 25,000 at 38%, 25 to 50,000, 15%, 50 to 100,000 at 6%, and 42% at over 100,000 in population. So thank you very much for responding to that poll. Now I'd like to introduce the two speakers for this event. First of all, we have Kaustubh Page. He is the Senior Director of Product Management with 4M Analytics. As a product executive for over 20 years in infrastructure, AEC tech, and geospatial AI, he has led a platform strategy and launched high-impact products at 4M Analytics and Bentley Systems, ranging from utility AI agents to digital twin platforms. Our second speaker today is Dan Colbert. He is the Geospatial Sales Manager for Utilities with Trimble. Dan is a utilities industry specialist. He's got over 20 years experience in high precision GNSS, mapping and surveying, and GIS industries. His work centers on optimizing field data and collection workflows and designing system integrations for enterprise level operations. And as an expert in Trimble GNSS systems, Dan frequently leads technical seminars and pioneers go-to-market initiatives for groundbreaking utility technologies. As you can get a sense here, these presenters are knowledgeable and well-respected experts and represent companies with decades of experience and success in utility mapping and related disciplines. Dan and Kaustubh have in-depth familiarity and experience with the types of issues and problems you are facing, and look forward to answering questions after their presentations. As mentioned previously, today's webinar will focus on mapping the hidden city, capturing locations and data about underground infrastructure, and using that information to support planning, design, and operations. In this session, you'll learn about modern processes, techniques, and tools supporting utility mapping and how these are applied across infrastructure design, construction, and operational use and maintenance. So at this point, I'd like to hand it over to Kaustubh and start the presentation.
Okay, thanks, Peter. Let me quickly share my screen.
While Kaustubh is rejoining, I'll introduce myself. My name is Dan Colbert with Trimble Geospatial, and we've had the pleasure of working with 4M over the last 18 months or so to iterate over some ideas about how we bring utility technology in a new way to field workworkflows. And I'm excited about the opportunity and what this really brings. And more than anything, I hope today's webinar and exposure to this technology gives some of you an idea of what's actually possible when we bring these types of technologies together. So I appreciate the opportunity and the partnership with 4M. And I'll turn it over back to you, Kaustubh.
All right, thanks, Dan. Guessing you guys can see my screen now?
Yes.
All right, perfect. Thank you. Yeah, sorry for that technical difficulty. I'll switch to my new laptop so you know how things goes. And some of the things were not enabled. So here we are. Lesson learned: before webinar, make sure the screen sharing on new laptop is tested. So now we have that out of the way. As Peter was mentioning, Dan and myself, we are here to talk more about utility mapping, what is the current practices and how it impacts the entire workflow, and how to do it without surprises with the new technology. And we'll be going over what 4M provides from a utility data perspective. And with that, after that, we will look at the integration between 4M data and Trimble, and Dan will walk you over different ways the 4M data can move through Trimble ecosystem, and we'll be happy to get your feedback, and in the question and answer session after the presentation, would love to hear your ideas too. So with that being said, I know this is a busy slide and I wanted to start with this, but this is how our industry is. It's not an easy thing to execute an infrastructure project, right? There are many disciplines involved, many groups involved. The project goes through different phases. So starting with the top one, like project management, you are planning with a project. You want to make sure in that planning phase, all the risks are captured. Many times the risks related to the unknowns, and on most of the infrastructure projects, the unknowns are everything that's hidden, right? So the way I term it, there are two major unknowns. One is utilities, and another one is geological, like soil conditions, right? Those two can have severe impact on how your risks are addressed and how much budgets you have allocated for the risks, so on and so forth. So here are different stages of the infrastructure lifecycle. Here are different groups that deal with it. In this particular webinar, we will focus on utilities and how utility coordination and utility conflict management, utility design, how it affects. But as you can see, the utilities itself, they affect the right-of-way acquisition, right? They affect the design, they affect the environmental, they affect the planning and programming. So it doesn't work, or the effects are not restricted within one discipline itself. Rather, it's distributed across the entire lifespan of the project. And in worse situations, we have seen utilities which could have been detected early on. If they didn't get detected, then the effect of that, the domino effect of that, is in the construction side when they are found. And because they are found so late in the game, there are all sorts of delays. That delays cost to extra cost to the owner. Not only that, if you are, as most of the audience in this webinar is from the public side, delays to public, right? Disruption to traffic, inconvenience to your constituents, and that's the worst outcome that we could imagine. So we at 4M, what we are trying to do is we are trying to redefine the access to utility data, when it's available, how comprehensive that data will be, and how we can apply new techniques. The technology is evolving significantly with AI and whatnot, but how we can still be careful enough where we are not trusting AI and saying, oh, AI is going to solve the world hunger. Maybe one day it will, but as of now, the way I see it, it's an assisting tool to engineers, to planners, to decision makers. And how can we build that right product where we are providing the data, but with the right evidences? We are empowering the decision makers with the data. At the end of the day, the decision needs to be taken by a human, needs to be taken by engineers, so on and so forth. So before we move forward, I would like this audience to get a sense of, what do you know about subsurface utility engineering? Are you using that? If you are using that, what is the level of subsurface utility engineering you are using? So with that, please answer the poll. I'll take a pause here for a few seconds for you to answer both of these questions. And this will help us even have more meaningful discussion during the product demonstration and also in Q&A.
Please, everyone, go ahead and submit your answers to the poll.
Yeah, and as you are submitting the answers to this poll, one thing I want to clarify: 4M as a technology, it's not a replacement for SU, right? It's actually enablement for the SU. So, all right, we got the response back. 33% use SIU, 16% familiar, but they do not, and not familiar, 51%. So large audience over here, more than 50%, you are not using SIU, which is perfectly fine. So SIU stands for Subsurface Utility Engineering. There is a practice. Many states use that. For an example, Colorado is a leading state where SIU is mandatory for all of their DOT-related projects, right? And I think with a new law that got passed for many municipalities, that is also applicable. In terms of what level of SIU you are conducting, it's record research, most of it, and some of it are taking it all the way to quality level A, which is great, and then rest of it quality level C. This is actually a great data point, and as we go through the product demonstration, I'll talk about what we are delivering with 4M, how it's equivalent to SIU level D, and in some situation, it can be also SIU level C. Again, there are some details, so we are not an engineering firm. We won't stamp things, but this is a very important context. So thanks for this answers to this poll. So now let's look at the traditional way of investigating utilities, right? So if you're designing a project, you want to know who are the utilities present within a particular area of interest. Usually you will submit a ticket in 811, right? 811 system. That ticket could be design ticket if 811 supports it. If it doesn't support it, you have to submit literally a dig ticket. What happens next is you will get some response from the utility owners. If it is a design ticket, it might be lower on utility owners' priority. So there might be a situation where you don't get any response. Then for those who you get a response, there could be a hand sketch provided like this. And I'm not making this up. This is a response to an actual ticket. So an actual ticket responded with a sketch like this. Hey, here most probably our utilities are. And then you are responsible for digitizing it. So you have to manually either stitch that data together, or you have to go and visit the site location to look at the spray paints and then figure out what is the actual site condition. So this workflow, it's time consuming. So on an average, you will spend weeks, if not months, on a large linear project. Even it doesn't have to be large. Even let's say you are doing like a sidewalk enhancement or sidewalk upgradation, you will spend weeks on an average or months to collect everything. Once you collect it, then transferring it and converting it to a digital format so that your designers and your planners can use it in more meaningful ways along with other tools. So with that being said, what we, as a company, what we decided to do is we wanted to launch a product where AI is, it's AI-centric product. And we want to use AI to find information about utilities. How we are doing it? So we built something called AI conflation engine. What it does, it collects millions of data points. Those data points are PDFs, GIS information, permit records. Even we look at some of the social media records, like, hey, let's say from a property management website, is there a sewage tank or septic tank on a house? If there is, then most probably there is no sewage line going there. So we do this data collection, and surprisingly, in an urban environment, rural is different, but in an urban environment, it's not lack of data, but it's too much data. So what I'm showing you over here, this is our data collection engine, which goes and collects millions of records. When we say, okay, all these collected records, how do they look like on a map? And this is a water network. This specific one is actually a real example in Dallas area. So when we collect all these public records, this is how the water network looks like. One record is saying the water line is on the left side of the road. One is saying it's in the center of the road. One is saying it's on the right. So if you really plot it, the whole road is filled up with water, but that's not the case, right? So that's our step number one. Then what we do is we have built, as I was mentioning, this conflation engine. That conflation engine, with support of image science, imagery analysis, it removes duplicates. It does CRS normalization. It normalizes the schema. It enhances attributes based on other data sources. So it's like combination of multiple data sources together to figure out which is the right metadata, and also removal of a lot of the noise in the system that we have received from public domain. Then on top of it, we also add object detection, meaning the on-surface objects, for an example, for water network, hydrants or valves, we detected based on our imagery science. So we process street level imagery, we process aerial imagery, we process high definition satellite. So it's not one type of imagery source that we process, but we process multiple of them together to create this map. Because processing an image is relatively easy, positioning those objects correctly on a map, it's a difficult task. And now recently, we've also started to identify road marks. Right now, we are going back about 12 months and capturing the street level imagery and identifying road marks. By end of April or somewhere in Q2, we will have ability to go back in time about 10 plus years and identify road marks across multiple years, right? So that's the feature that we are working on. And then we are also working on an ability to for AI to generate lines based on the evidences. So those evidences are road marks, on-surface objects, so on and so forth. So these lines were never present in any public record. And when I jump to the product demo, we'll talk about scenarios like that. So this is the AI conflation engine. And the result of it, we are running it at a scale. And across multiple different sectors. And as a result of it, we get a product that we have built. So with that being said, let me jump on to the product. So 4M is a SaaS service. It does not require any installation, any pre-configuration, so on and so forth. So this is the product view. Here for this particular account that I've set up, it has multiple states where I have access to. In principle, what you can do is we have pre-mapped a state. So I can go anywhere within a state. For example, in Colorado, I can go over here. I can say, create a new project. I can start drawing a polygon like this, and that could be my new project. Or I could start over and let's do an upload of polygon. So I can select a KMZ or a KML file like this and say open. So here's a project area. You can integrate this with other systems of your choice. So we do have a project creation API now, so you can create an integration. Let's click next. Let's call this a road improvement project. And project phase, we just want to look at the conceptual study of road improvement over here. Type is road, and let's look at the utility map. So once I click on that button, again, any area within a pre-map state, because we have created this predefined map, we can now go and start looking at the utilities streamed right away. And you saw a couple of pop-ups. So there is a enhancement to a data, and there is also this object detection. This usually takes somewhere from 15 minutes to 1 hour. I've already finished this on a same location on other projects. So let me just switch that. So this is how a completed project looks like. Again, we have rich data. For the demonstration, let me just start with the lines itself, right? So for the lines, here are the lines that are collected. We can tell you what type of line it is, what is the dimension, what is the type, and we can also talk about source. So over here, this particular line, City of Greeley is where public records from City of Greeley is where we found that line. And then we could click on something like a petroleum or natural gas, and this is 4M proprietary. So that means we have generated these lines based on the evidences, right? But again, these records are just indication that something exists. And from an engineer's perspective, by the way, I'm a civil engineer. I was once licensed in state of California, PE from California, although I don't hold that anymore. I haven't renewed in the last many years. But when I look at this data as an engineer, okay, this is a good indication that lines potentially may exist, but I'm not going to trust it as it is. Now let's turn on the other evidences. So we have turned on our objects, and let's also turn on our markings. So once we have turned on the objects, let's look at this particular configuration. So on the lines, let me turn off all the lines and just turn on these two. So, okay, we are saying there is an underground power line, okay? And we are also showing you there's a street lamp. And if I inspect this, yeah, most probably there has to be a line going to this. So my confidence in this line increases a tad bit. Again, I'm not saying completely trust this, or me as an engineer, I'm not going to completely trust this. But now let's enable another level of evidence. Maybe I want to go to a particular location in this map. Yeah, I think we were fine where we were. So let's turn on this, right? So here, if I jump on and I start seeing the evidences, like the markings on the ground, another location that we can also look at is these red marks over here. So for an example, I can go and visually verify. I don't know how much clear it is from the screen sharing, the road marks on the ground, but here are red road marks that we have detected from the street view analysis or street level imagery analysis, and we have geolocated or geo-referenced those road marks. So here's the actual road mark. Here's the line that we got from GIS record. I can go to measuring tool and let's measure the distance. It's about the road mark and the GIS record was about 1 feet off. So with that information, this line, the underground power, is a little bit more trustworthy to me. So if I have to rate this line again from that SU level quality levels, I may rate this, hey, this is C plus, because I have this evidence of road mark. I have a street pole over here, and me as an engineer with these two strong evidences, I can definitely say the line is within 1 or 2 feet band of this, right? And then when you are planning, let's say, sidewalk expansion or sidewalk repair, you exactly know with strong evidences a line exists, underground power line exists over here. So when you're going on a site where you are rather even budgeting for this particular project, you can budget accordingly. So you are dealing with an electric line over here. Another example I would like to demonstrate is in this area, okay? So in this area, we do not have a strong, or we do not have a GIS information talking about gas line going off to the property. It was never recorded in any GIS information, but here I can see a spray paint on the ground marking the gas line going to this property. Based on that, and based on what I can see over here on the map, I can say with fair confidence somewhere within this band. Again, road marks could be also from a geo position might not be 100% accurate, but this is the best in quality information that we can get from the evidences that we have available. So I can confidently say, all right, there's a line that goes, it's a service line that goes to this. So any modification, again, I'm doing in that area, I need to be cautious about. So what we have done is provided you an ability to get this utility information at scale. So we have in this project about 45 miles or 46 miles of utility lines delivered, about 1,700 or close to 1,800 objects, and plus the road marks, right? So all of this is delivered within a matter of hours because our object detection runs for this size, maybe 15 minutes to 1 hour. So within 1 hour, you have this comprehensive information. You can also go and look at utility owners. So we provide a complete list of utility owners who are available in this area for you to go and coordinate with. We also have other tools. For an example, there's an insights tool which looks at this entire project. It looks at the different utilities that are present within that project, and it tries to, first of all, plot those utilities which are within the right-of-way, outside the right-of-way. There's a parcel information. It tells you how they are traversing through different parcels. If you are looking at right-of-way expansion, then you understand which utilities are where. It also identifies some of the large diameter lines. So it looks like there is a 24-inch wastewater line. I can go and click on show only, and it should show me the 24-inch line on the map. Maybe that is a little bit outside. Let's try another one. Okay, here. So these are, maybe the 24 inches also there. So here's like a 4-inch line that is identified. So you can go and look at individual diameters. You can also go and look at different types of crossings. You can also turn on the parcel information. This is extremely critical. So you can, let's say for this specific location, you want to go and look at who this building belongs to. So it looks like it's a school building by District 6. You can also click at some other properties, look at what is the land value, what is the parcel cost, so on and so forth. So all of this is available within, as I said, matter of seconds or matter of minutes instead of hours and instead of weeks and months. So that's the platform. We do have a couple more workflows, but because of the time constraint, I'm not going to go into those workflows. What I quickly wanted to show is you can download this information. You can also download list of utilities. We also generate automatic CAD. So the CAD output for that particular project looks something like this. And if I have to zoom into one location, so this is fully automated CAD. It will show you the line types. It will also show the markings on the CAD drawing, right? So when you send this out to your designer, not only the lines are marked with the correct terminology, but also the markings, the road markings that we were showing, that were also exported to the CAD side. Okay, the last part I want to demonstrate is about our API keys. So what we can what we can generate in our platform is ability to stream information from 4M, the data that we saw, to other platforms such as Trimble, right? So here is a web feature service URL. You can create a new web feature service. You can set a coordinate system for that. You can set an expiration date for that. And you can just share this for any other system to start streaming that data. So I generated this literally today morning and shared that with Dan. So with that, Dan, I'm going to pass the presentation to you. Why don't you talk about what you can do once you get this WFS URL on the Trimble side?
Yeah, thanks, Kaustubh. Yeah, this is awesome stuff, and I don't know if those of you who are involved in the Sioux records research process, the ability to bring this down to a matter of minutes is an absolute game changer in your workflow. So as Kaustubh said, and hopefully, let's see if can you just give me a thumbs up, Kaustubh, that everything's sharing okay? Perfect. Yeah. Is that you generated the API key here, this webinar 2026 API key. But what that really gives us the ability to do now is to connect the 4M outputs and this rich generated utility data for the purposes of taking it out into the field and updating it and verifying and validating, and where it's necessary, make sure to increase the your confidence in that data, whether it's elevating it through the quality level systems, or just verifying that the location of the utilities in a real world context is kind of the next logical step and progression of this data. What you're looking at now, though, is Trimble Connect. It's a platform that exists to aggregate geospatial data of all types, whether it's GPS data that you're collecting from surveyors, or if it's mobile mapping systems and point clouds or imagery data. Trimble Connect is a platform where all of that data can be conflated and shared. And now bringing in the data from 4M gives another layer of context to a construction project. What I'm going to show you now is how we can take that data from 4M right out into the field and bring a real world context to it in two different flavors. The first thing I do want to show you, though, is as we took that API key, what we've created is an extension to this Trimble Connect platform that allows us to bring in data directly from 4M. So it's as simple as just pasting in the API key and finding the right project as defined in the 4M site. We've got the webinar 2026 9th and 10th with road marks project. And just a couple of clicks later, I can verify, and I can even overwrite the coordinate system as this data comes in to make it match existing data. We're going to give this a friendly name here. And then as simple as a single click here, we can bring all that data from 4M into Trimble Connect. And once that data is inside of Trimble Connect, it opens up a world of possibilities in terms of how that data can be used. And I'll show you a couple of those here now. Today, the integration represents just a single move of data from 4M to Trimble Connect. But rest assured that we really want to create a platform or a location or a source of truth for this utility data. So imagine that as we're looking at this data in the field, and as updates are made in the field, whether it's spatially or attributes, that data coming back from Trimble Connect and then being placed back into 4M as the authoritative record for utility data. So that's our ultimate goal here, is to create an elevated sense source of truth for utility data for a given project. And as you can see here, the data has been copied successfully. And if we just go quickly look at that data, here's the Greeley project demo. And I'm going to load this into a map viewer component of Trimble Connect so that you can see that the data that came through here is in fact brought directly into our platform and can be used inside of Trimble field workflows. So just a click here and a zoom in, and you can kind of get a sense of the data that Kaustubh demonstrated earlier is now in a Trimble Connect environment, along with all the attribution that were pulled across into including utility owners, and if we know any depths or material types on any of the utilities, all of that stuff is brought through. The rubber meets the road, though, when we do bring this stuff to the field. So what I want to show you now, and I apologize as I turn my back to you, but it's a little bit difficult without being able to go out into the field specifically. So a little bit of a demo up against the wall of my office. But we want to take this data out and visualize it in a real world context. And we're going to do that using a product called Trimble Site Vision, which uses augmented reality to overlay this data directly from 4M into a real world context. And it positions you using high accuracy GPS with just a single couple of clicks. So as quickly as I move that data from 4M to this Trimble platform, you can see that this data is now instantly available in something like Site Vision. So what I'm going to do here is, because I'm sitting in my office here, I'm just going to zoom out and manually place myself on this Greeley project somewhere. So as I zoom in, I can let's just say have an idea here. I want to place myself at this location. and then I can just have a quick look around for all of this utility data. And the point here is that you can now visualize yourself, or I'm asking you now to visualize yourself walking on the street in Greeley, Colorado, with all of this utility data overlaid on it. And as you pan around, that utility data overlaid on the real world as evidence, and you're getting an idea of whether the data needs to be updated or needs to be enhanced, or if something has been missed. So you get a good idea of what's happening simply because of that real world context. But then you also have all of the extended utility data that came directly from 4M. So ideas about this particular water line with a 6-inch diameter and depth of 48 inches, and of course I've symbolized it here so that as data comes in, hydrants look like hydrants and valve covers look like valve covers, and obviously the different types of data that come through are symbolized differently. But the idea that you can take this data out into the field with just a couple of single clicks is a really powerful thing for adding context to your utility investigation process at the front end of a project, to give you an idea of perhaps maybe where you need to invest more in SUE A or SUE B sort of discoveries, rather than having to do the entire potholing every 50 feet. There's a particular intersection or location of utility data that represent a higher risk to the project, and you can focus your energy and your budget on the right parts of the project. So Site Vision is an excellent tool for that visualization component. If you really wanted to get down into the weeds and start taking this to the next level, there's other products also that use the exact same data. So something like Trimble TerraFlex is another opportunity for you to take this data out into the field, and with just a couple of clicks, we can now do the attribute updating and the spatial component updates to the utility features. And if we wanted to do things like hone in on specific tasks, let's look at those features that 4M identified by with kind of visual evidence, things like manholes and valve covers that may not be easily attributable to one particular type of feature or utility sector, if you will. We can capture all of those and very quickly use TerraFlex we can even navigate to, obviously I'm down here in Denver, 60 kilometers away, but you can use TerraFlex to navigate you to that feature so that you can be sure that the manhole that you're looking at is the one that's identified on the map. And then once you get there, you can update the utility information, and now that information can flow back to Trimble Connect and ultimately back to the source of truth, which is 4M for that project for the long term. So there's a huge power in the connection between 4M and Trimble that give you greater confidence in your utility data as you progress in the project phases. But Site Vision as an investigative tool, and then TerraFlex or other Trimble tools in the field for updating that data, and then the fact that it's all in this shared cloud services allows us to move data back and forth between those systems easily. So some powerful stuff. I'm really excited about the work that we've done together and will continue to do together to enhance this workflow. Awesome. So Kaustubh, I'll turn it back over to you.
All right, thanks, Dan. What I would like to do is actually share actual site video that we did in Atlanta, working with GDOT. So here's a video. Me and Dan, we were out there on one of the project on Marietta Street. I don't know how much it's visible from the screen sharing, but there's a manhole over here, and we could see that on the device. And with this GNSS setup, you could, and Dan, correct me if I'm stating it wrong, but you could have any mobile phone with this GNSS stick, and you just literally walk 10 steps and everything aligns. It was like magic to see that actually working on the field. So yeah, here's a quick demonstration. You could take like a section or you could remove that, so you could see below the ground, and you could change that transparency and just look above the ground. So it's really transformational with tools like this from Trimble, how our data can be the seed data for any of the workflows, right? Some of the workflows that we are seeing with the government sector is emergency response, right? So many of the times, emergency repairs and responses, those projects are very fast-paced projects, and they need to be finished within 6 months or 8 months, and they just don't have enough time to go and investigate about utilities. So technological integration like this, data starting from 4M, then sent to Trimble, and you can just go on the site, and instead of starting from scratch, literally a good enough data set, which I was showing you is comparable to, in many situations, level C or even more, right? So that's your starting point. We are seeing many public agencies reducing their time in the field. Many public agencies are, again, as I was mentioning at the beginning, completely changing their risk profile on various projects. So with that, this concludes our webinar presentation part, and we would like to open it for Q&A. Peter?
Okay, well, I'm back. Kaustubh and Dan, thank you very much for those presentations. Really, really pretty cool stuff. I want to, again, invite all the attendees to put any question or comment you have into the Q&A box, and we'll get to that shortly. I wanted to kick off this Q&A, letting you, Dan and Kaustubh, if you have any summary remarks. And I think I'd like to start that with Kaustubh and ask if you could sort of at a high level contrast a more traditional approach to underground utility mapping and GIS database development with the 4M tools, which I would sort of characterize as a data-rich, source-rich kind of environment for capturing location.
Yeah, and I kind of touch base that on the initial part of my presentation, right? So the current way without use of modern technology is a lot of boots on ground, a lot of coordination with 811, a lot of phone calls to utility owners. So it's a painful process. I don't envy anyone who is involved in that. And many times it's like, okay, you have to reach out 10 times and maybe you'll get data and maybe you won't get data. And the result of that is you just have to work with what information you have, which is kind of it's a risky and at the same time kind of a sad state to start a project, right? When you're starting a project, you should have all of the information, at least a high level idea of where it is. So to answer your question, Peter, the current situation, as I said, lots of boots on ground, lots of manual coordination. The information that's passed between different entities, it's non-digital. It's like hand sketches, back of the napkin sketches that are literally shared as, hey, here our lines are, go figure it out. So yeah, we are trying to literally change that initial conversation enabler with 4M.
Okay. Before we go to questions from the audience, I'm going to jump in here with a couple of mine, and then we'll get on to the others. Really great examples, Kaustubh, and the demo that you showed. Do you find in practice that this utility mapping works better when you're starting with at least some level of GIS data, utility mapping in a GIS?
Yeah, so I'll walk you actually through a couple of examples, right? So one is a project in Houston area, and on that project, the initial concept study, it is a bridge project, right? So the new bridge is about to get installed in Houston downtown area, and the initial study and the alignment on the bridge, somehow the first engineering company missed a sewage line. It was 144-inch sewage line depth with 54 feet deep underground, right? And they completely missed it. And the foundation was placed right on top of it. Then another engineering firm was involved, and they used our technology, and they were like, okay, 4M is already showing a line in this location. It's a sewage line. It's a large diameter sewage line. We need to go and investigate. So what happened is, because of that early signals from 4M that something is present, the DOT actually sent someone to do in-pipe inspection and figure out if there is a sewage line actually present. And they found out the sewage line is present few feet off where we were showing as part of the record, right? So identifying these things early on in the concept phase has saved that DOT, I don't want to put a number, but potentially millions and millions of dollars. Because think of conventionally where these things will be identified, they get identified towards 60% of design. That's where you go for a full-blown or subsurface investigation. In worst situation, they get identified when you start actually drilling for foundation and something happens, right? That's the worst situation. So by utilizing our tool, this is a real life example that we saved a major delay on a big project. Another example from another DOT, they did actually SEW level B on a project, and that SEW level B did not find a water line, which was on top of which a sound barrier wall was placed. So 4M identified that water line, and that DOT is actually using 4M as a QA/QC to SEW level, right? So it's like in complementary with what SEW is subsurface utility engineers are providing. They are verifying, okay, what are the evidences 4M is showing? Are there any previous road marks? And if they were, what happened to that line? Maybe the line got removed, right? So those road marks are not available. But that type of scrutiny or that type of higher level of inspection is enabled. So on that specific project, because we identified that water line, the DOT avoided a major delay to a project because it was a very long sound barrier wall. And they were just explaining to us, if this was found in construction, then the domino effect kicks in, right? So the contractor is obviously delayed for that specific project. And if they have a backed up project after that, then the DOT has to pay for delays on current project and plus the upcoming project. So by identifying these lines, one or two lines, right? And I'm not even talking about hundreds and thousands of projects that we are seeing with DOTs. By identifying even one line, that could be an impact of millions of dollars in construction cost. And we are seeing real use cases.
All right, Kaustubh, thank you. I'm going to go to questions from the attendees. We'll just go down the list here. First question, I think this goes over to Dan. It says site vision is much like taking a plot of the project collected survey data and see how it compares to what the engineer can see in real time on the surface. Question is, can the survey data be loaded into the Trimble site vision directly without the 4M data set?
Yeah, the answer is yes. That site vision is designed exactly for that. Is designed for visualizing all manner of data, whether it's a 3D model or if it's an alignment. Yes, absolutely. Where 4M is another layer of information on top of that view, it is site vision is designed for viewing engineering data overlaid in a real world context. Absolutely.
Okay, thank you, Dan. Another question: do you assume a depth to provide a 3D model? And I'm going to just add to that because it's really a question of how do you capture any attributes about those underground utilities. But in the case of depth, what sort of sources or cues are you looking for for a depth location?
Great question, right? So for depth, as of now, we do assume, and we are working with a couple of DOTs where we are actually looking at their standards and then just saying, okay, based on the standard, here are the depths, the depths that should be, right? And it's never followed to the standard. All of us over here know that, but at least that's the starting point, right? because this is a preliminary level investigation. This is how you start off with. The actual depths, to be honest and frank with the audience, you will get that only after you do a borehole, right? Only after you do vacuum trucking and look at where the pipes are, that's where you get the actual depths. What we are working with many agencies is collecting this borehole data and then creating, because we can ingest it at a scale, we can then start creating the points of depths across these distinct or discrete location. And what we are working towards is in future creating a probable depth map or depth bands for different utilities in different region. But again, to accelerate that, we need more partnership with public entities. We need more technological partnership with someone like Trimble, where they also collect a lot of this information. So depth is the next frontier for us as an industry. We are getting towards it.
Okay, this next question is for both of you, and I can see that it could get a little involved, so you guys can maybe take a crack at it. But if you want to suggest that, a follow up with the person who submitted the question outside of this webinar, you can do that. But it says, I want to work with 4M data in combination with my SU DCBA results. How can I do this?
And Dan, I can take a first stab at it. So yeah. We are seeing a couple of ways that are evolving. One is if let's say you're working with SU level A, or maybe A is too much, but B, SU level B, the deliverables usually are CAD drawings. Sometimes they are also like GIS, KML, KMZ files. I already showed you the CAD output. Many of public entities, what they're doing is taking the SU level B, putting our CAD output on top of it. We also show the road marks and evidences through our CAD output and compare it one by one. That's one way of doing it. And then I'm guessing same workflow can also enable on Trimble side, and I'll let you answer to that.
Yeah, identically. I think our emphasis from a product standpoint, so that you can conflate data from different sources or from different entities, even is I'll answer it on the platform level, that we want to make sure that data in a Trimble system, just as 4M has made sure that that data in their system is available to the downstream processes that need it. We provide APIs in the same way that 4M does, so that data can be used can be used readily and efficiently and quickly as a direct connection from one system to another, as opposed to moving files around. I know there's some processes that will always require a DWG or a KML to ingest, but and our system can provide that just the same as 4M. But again, our emphasis going forward is on providing connectivity to systems to enable that conflation of data from various sources to support the entire SU process.
Okay, great. Well, the next question is about the cost for the services and a pricing schedule. You don't need to answer that live here because it depends on a lot of things, I guess, but I'll throw that out to both of you for the products and services from Trimble and 4M.
Yeah, so answer is we do have different, it's a yearly subscription model from 4M side, depending on and it's kind of also a consumption model. So depending on what is your how many linear miles of data that you need, we have different pricing tiers. So we can definitely connect offline, Kenneth, and answer you more. But it's a yearly subscription model. The pricing is based on linear miles. So that's the approach on 4M side. Dan, you want to answer from Trimble?
Yeah, and from a Trimble perspective, it's also an annual subscription for access to the software and components that are needed to support the workflow that you saw today. And we're happy to connect you with the right Trimble distribution partner in your area of the world, or the U.S. specifically, to get your hands on the product and also for the detailed pricing based on how you may deploy it in the field.
Okay, great. Next question. I'm actually going to take a crack at this and then hand it over to you guys, but it has to do with do you have accurate parcel data that is survey grade accurate? I'm sure that the answer to that is it depends. If it's a recorded plat or some other property survey, yeah, it's survey accurate because it was done and it was approved by a licensed property surveyor. But is that plat or property survey georeferenced in any way? And then you run into questions. Well, if you're dealing with parcel data that's in some organization's GIS, those parcel boundaries, depending on where you are and what the sources are, have a range of boundary accuracy. So I'll just say, yeah, maybe, but it depends. You guys can maybe talk about what you've encountered in various projects.
Yeah, you're spot on there. So yeah, answer is it depends. We do rely on a couple of third-party vendors to get that data and what our observation has been. And it's actually kind of funny. Many of the DOTs that we work with, they also rely on the same vendors to get the data. So it's not like DOT themselves has better quality of data at a scale, right? But so depending on the actual surveys and plats, in some situations, yes, you have to go in and you have to fine tune that. There is an effort that's going on where we are looking at old scanned right-of-way drawings and some of the survey data and trying to digitize it. But again, we are not there yet. So I would say, yeah, you answered it correctly. It depends.
Yeah, and I'll say that that one of the opportunities for the use of something like sight vision and augmented reality is project stakeholder engagement. And one of the key stakeholders for many of these linear projects are landowners, and communicating the relative activity that may happen either close to or infringing upon their property boundaries is a key opportunity for communication. And as you said, Peter, that we can't really rely on the survey accuracy of that plat data, but it certainly does help in communication with stakeholders. But we do have to be very careful about communicating a project or a property boundary when in the field, because we just can't rely on the accuracy to the level that's necessary.
Okay, let's keep going. The next question: do you have ground elevations available survey grade? It's sort of related to the question on depth, but yeah, we're dealing in 3 dimensions, and that's pretty important when you're talking about utilities.
So from 4M side, no, that's not something we do. We do not have it available. But I think our from where we want to go, right? Our product direction is not to go and figure things out which are survey grade, which is always a hard problem. And that's where initially what I was mentioning, our aim is not to replace engineers. That is, I think, still a surveyor's job to go and find things which are survey grade and stand by that surveyor. But our ambition is to reduce time on the site, right? So with that ethos, we won't have ground elevation at survey grade provided by 4M. Dan?
Yeah, that's not where this data starts, right? The data starts with the ability to do utility investigations in a more effective, cost-effective manner. Connecting this data to Trimble downstream workflows, though, do enable you to elevate your confidence. How about that word? I didn't even throw that in there on purpose. To elevate your confidence in the elevation with the appropriate tools in the field. So you can absolutely derive elevations from survey practices using the 4M data as a basis, but that's not going to be done at the front end of the project. But that is absolutely something you can add as part of the workflow downstream.
And I'll just add to that, my experience over the past 15 years is that sort of general purpose elevation data, data being collected by local governments, counties, cities, now primarily through LiDAR, and then processing that LiDAR data, creating products, digital elevation model products that can be used in a GIS. It's a whole lot better than it used to be. It's gotten a lot better. It's not sort of survey grade elevations, but it's pretty darn good stuff. And that, I think that trend is in elevation data is going to continue to improve both in resolution and vertical accuracy. Okay, next question. I'm the survey manager for the city. Our city is both a utility provider and engineering project designer. Yes, the 811 process is greatly frustrating for what they do not respond to. There's also legal liability to collect what locates marks are painted on the ground and what is brought in from different sources like record drawings. I like where the 4M is going and a great tool for concept phase and planning basis. Subsequently, may indicate where some GPR may be necessary, ground penetrating radar, to thread a new utility line through a particularly busy location. Do you find the 4M data is useful always to the construction phase? So the questioner is sort of comparing sort of the planning and design and then using that going into construction.
Yeah, and I think there's a correction that was later introduced. I think he meant to say 4M data is also useful in the construction phase.
Okay, all right, sorry.
Yeah. Yes, as we engage with DOTs, right, we are actually surprised of the usefulness of the data. Because our standpoint or the way we are building this product is, yes, it's for concept studies, for preliminary planning. We are not going and saying, hey, this is the final data that you should rely on construction. But the reality of world is many of these DOTs are doing, as I was mentioning, emergency projects. They are doing resurfacing project without any site investigation on utilities, right? So it's like, when you have, before 4M, there was no utility data and the project manager was kind of responsible to go figure things out. And with 4M, they're going to the site with some understanding of the data. So we are seeing transformation of some of the emergency response crews across DOTs who are now using 4M as a standard, right? They are obviously, they have this understanding that this is not a big grade data, but their point is this is way better than not having any data, right? Mm-hmm. So again, we are not proposing this is construction ready. We want to get there, and that's what we are working towards. But the technology and the AI and everything that's out there right now, it's still applicable on the conceptual phase. But we're seeing already use cases in traffic management and emergency response and in putting our data for letting process for road resurfacing. Because what some DOTs are doing, they're taking the utility on-surface objects, converting that to CAD, and putting that in their letting process, saying, hey, here are identified manholes and valves within this. So without sending any survey, they have a letting package, which they can validate using our evidences, right? So we are getting surprised on that front.
All right, next question, kind of a segue. Can you share how field data collected during a project is handled downstream? Specifically, how or if that data flows back into 4M models or other systems in a way that can benefit future projects in the same area. In other words, how 4M handles as-built drawings. And I'll add to that, it was a question of mine, Kaustu, when you were talking about some of the data sources that you ingest in the 4M AI tools. Are you talking about plan engineering drawings or other drawings as well, and sort of how that works, how you georeference it, all that stuff?
Yeah, so first part of the question, right now, the integration that we have with Trimble is one way, right? What we demonstrated is data coming from 4M, going into Trimble Connect, and then multiple products. But as Dan mentioned, the vision is to build this feedback loop So that's something we will start. We have already started working towards, and you will see more progress towards as the year progresses. So the vision is you take the data with Trimble tools, go out in the field, and you make edits and changes, and there will be a sync functionality available where that data comes back to 4M, and 4M is that centralized utility repository. Now, what we are working on 4M side is once that data comes back, this is user-specific data, so we don't want to update our generic map that we have built, but it will be organization level layer. So for an example, let's say TextDot implements this process, right? So we will, all of the data that we are getting as a feedback from Trimble devices, that will be a TextDot specific layer only available for TextDot as an organization. So anytime they, let's say, create a project within the same location in future, instead of showing 4M base data, it will get replaced with that as-built data. That's one type of process. And this one actually has another question hidden in it, the as-built drawings, right? So we are working with many DOTs where we are ingesting PDFs, vector PDFs, and we are processing those PDF at scale. So thousands and thousands of PDFs where we are extracting the utility data. And again, we are not providing that as part of 4M provided data source, but it becomes organization specific. So DOTs and in some situation, even utility owners, they are working with us to build that organization level layer, which is created by their in-house PDFs, which are not in public domain.
Okay. One other follow-up to that question for Dan. When you showed the Site Vision tool, I was wondering, is there any kind of capability when you're out there in the field to do any sort of markup or update if you're seeing something in the field that you want to capture somehow?
Yeah, there are ways to communicate, places where further investigation needs to happen, or the data is obviously incorrect, or something has been omitted. Yes, there are ways to indicate that stuff while you're in the field. And there's Site Vision is one tool to create that. There are any number of tools that can serve that same process, that same purpose.
Okay, great. All right, next question. Really good question. How often is the 4M database updated to reflect new utilities, or maybe updated information about existing utilities? There's new data coming in all the time, right, Kaustubh?
Yeah, great question, by the way. And this was, when we started with our product, this was the challenge that we wanted to keep in mind, that many times what happens is you take this initiative of capturing utility data, and it's that timestamp, and 6 months later or 1 year later, it becomes stale, right? So our AI configuration engine, when it collects all these data points, it does have, let's say it collected publicly available GIS, right? It does have ability to go and periodically check to see if there are changes, then only take those changes, so on and so forth. So at a state level, we do run through this revision process about 8 to 12 weeks on a state level. So it's not, let's say something goes in the public domain, it's not like instantly we will find that. It does have some lag, but it's constantly getting updated. So when we started with Texas about 2 years ago, that's where we first launched, every single refresh has added about 5% of new lines and corrected about 7 to 8% of existing lines. So it's a continuous process where the metadata gets fine-tuned, new lines gets added, so on and so forth.
Okay, fantastic. Well, I think we're about at the end here. I could actually keep everybody on for another half hour and ask questions, but in the interest of time, I won't do that. We do have a compliment from Kenneth. Thank you for your answers. Great product for now. We'll continue to get better. And there's another question. I think this was kind of tongue in cheek. Will a PhD be issued? But I guess that reflects just a lot of good information about process and technique in this session, not to mention tools that are available now that can apply those. So again, I want to thank all of the attendees and your questions. I hope you got something out of this because I certainly did. And thank Dan and Cowstube, also 4M Analytics for sponsoring this session, and Connect Me for organizing and putting it on. Cowstube and Dan, any final remarks before we close the session?
Thanks for such a nice emceeing on this entire webinar, Peter. Thank you. This has been really engaging conversation with all these questions. So thank you to the audience for all these interesting questions. And Dan, yeah, we'll keep on working towards it. I think we have a lot of new features to develop as we progress forward. To you, Dan.
Absolutely. Yeah, absolutely. We're just scratching the surface of what's possible here. So again, I'll echo Cowstube and Peter's thanks to for your attendance and your engagement, and look forward to more in the future. Thanks again.
Okay, thanks everybody, and you will be getting a link for the recording for this session.
Thank you. Bye.